So my project began by laying out the hollow section on some stools outside because it could not fit inside the workshop while I was working on it. And me and my friend, instead of clamping the metal, decided to sit on it because it would be a more suitable and much faster method of holding the metal in place while I grinded it. So I've begun by doing rough cuts, so I wouldn't do the accurate cuts outside, just so then I could fit the metal indoors, and to make the rest of the project a lot easier. In my order for the metal, I ordered a lot more metal than I needed on purpose, so that I could do things like this and wouldn't need to order some more metal. We also labeled with masking tape and permanent markers what they would be used for. So after the rough cuts, the rough cuts would probably be from 15 to 20 centimeters extra metal on them to the accurate cuts on my 3D model. And then we made sure that all the pieces were cut and then brought them all inside. So you can see that I used the grinder for this and just went on each side of the metal going through it. It was pretty thick, but with the method that we used with sitting on it instead of clamping it every single time, we managed to get through it all in one double period. All the square box we managed to get cut. Then we began piling the metal into the corner just next to where we started. And here's a close-up of what it looked like. So I would mark with a permanent marker on the corner of the edge that I was going to cut, and then cut on one side almost as fast as possible. This is in 2x speed, and then I would go to the other side, pass the grinder underneath, and then I would grind the other side. And that would be how a cut goes. And now I did the same with the round tube, which is what I used for the suspension parts, but later I decided to use a kit rather than building my suspension myself, but I would still keep the steel tube in case I needed to extend any of the kit parts due to the amount of time I had for my project. So you can see I did the same sort of thing going around each side of the metal and cutting all the way through with the grinder, doing the rough cuts first. Here's a close-up of what it looked like. This is roughly in half time speed. Unfortunately, I didn't remember to wear an apron, and so that shirt actually got burnt a little bit on that little area that is next to the metal. And now I'm cutting through one edge of each end of the metal. This is so that I can mark from that straight edge to the rough edge and then cut that rough edge off. So this is now the accurate cuts of those two bits of steel using the cold saw. A very fast method of getting through the metal. After I'd cut all the pieces, I put it into a vice grip and started filing around all the edges so that it would weld a little bit more easily and wouldn't cut me or be unsafe to carry from the storeroom to outdoors. All the metal that I ordered came with primer pre-applied so that it could resist corrosion on the outside. Some lessons when the cold saw was disabled, I had to use a hacksaw to cut through, but then I realized it would be better just to wait for the cold saw to start working again in terms of time. So I did the same that I did with the tube, with the square tube, the square hollow section, and then marked off from the straight edge that I cut, so then I can cut both rough edges off and do the accurate cuts properly. All the spare pieces I kept just in case I needed them, and it turned out that another student needed it for their project, and I ended up selling it to him for feet on their I think it was a chest that they were building. So all the pieces of varying sizes all marked up properly. In the one lesson, I managed to get through all of them cut accurately, and then I put them in a milk crate in the back of the storeroom. So there's crossbars that I'm marking up here, so they would go from left to right of my project horizontally. That would keep the two sides together. And other shorter pieces would be like vertical short pieces, which would go from the bottom to about where the arms would rest. And then there'd be the diagonal pieces, which are probably the longest, which would, as you'll see through the building of my frame, would go from the base to the top point near where the engine would be protected. So here's all the crossbars that I was cutting. So the measurements that you would see on the tape that say 850, that's the rough measurement in millimeters of what it would be. So you can see I've got my Surface Pro or tablet, if that's what you want to call it, going in and out of frame, and that's what I used for the 3D model that I made for all my measurements to help me mark out more efficiently. For the welding, I used a falling leaf pattern with medium settings on the welder so that it can keep my metal nice and close together and have a nice big, well not big, but nice smooth lump going across of weld. Not too skinny, not too fat. After all my welds were complete, me and my friend Aiden clamped it all down and then started grinding away so that I could attach the vertical pieces onto the corners. Because if those parts aren't flat from the weld, then when you try and attach the pieces, they'll be either too long, too short, or they'll be on an angle when you try and weld them on. So this was a crucial part in the building of my project. This was the base rectangle. That would be at the very bottom of the project. Then I began to remove the labels and attach the short pieces. So we had a brand new welding bench that enabled us to clamp down our projects really easily and accurately, which was very helpful for the project. You'll see close-up pictures of these welds later on in the video. But I soon realized that I'd actually attached the wrong length pieces to this side, because I'd attached the long pieces to the other end, and this end was supposed to be I attached the short pieces to the other end, and this is supposed to be where the long pieces went. So I ended up having to grind down and cut off these pieces and then cut new ones of that type of piece out of the spare metal that I had ordered. Luckily for me, although there was vibration, my camera managed to refocus every time, which I was pretty happy about during the video. So once that was all flat, I clamped the piece and then got the parts on that I actually needed to put there. So using my engineer square as well, allowing me to keep it at a good right angle, 90 degrees to the base. So I'd do my tack welds first, and then I would unclamp so that I wouldn't damage the clamping equipment, and then I would do the proper welds around nice and evenly, filling in the seams so that no air could get inside the tube after I'd built the project. Or liquid for that matter. Because of the mild steel's poor heat conductivity, generally the parts after I'd grinded them would cool down quickly so I could weld on the new parts. And here I'm just grinding down the welds, not to attach new pieces, but just as a finishing touch to these welds. And then I painted them to prevent oxidization while I wasn't using them, just with some primer, one layer of it. Then I started cutting some more pieces, and these would soon become, with the angles cut out of them, what attached the top back to the base, as you can see what's happening in this video. So the armrests would attach to these diagonal pieces and then protrude forwards all the way to the front of the project using some shorter pieces. So I had to weld all around the seams, so I had to move my project and rotate it around so that I could get to each angle so that it would produce a good weld. And then I applied some more primer because I knew that I wouldn't be working on it anymore that lesson. Then I started marking out some more pieces, and this would become the rear crossbar. Using the magnets that the school had, I managed to hoist it up nicely and then tack weld it, remove the magnets and then weld it properly. Then I started cutting the angles, and this would connect the short pieces at the front of the project to the diagonal pieces of the project. The new clamping equipment that came with the table allowed me to do very nice clamping on angles as well. In some parts I had to skip the welding because they were on a very skinny angle and the head of the welding torch wasn't able to fit inside those angles, and I had to find a different way to weld it. Here's me just going over the seams on a different angle. I left the holes open on the top back of the project because I didn't know if I wanted to still have a removable roll cage or not. It was all a matter of time. So now I've attached those armrest pieces and I started welding them on. You can see at the front of the project, I've cut them in the short piece at the front and those pieces on angles, 45 degrees on each end, so it would fit nicely and look nice and square. Then I welded around the seams, but didn't weld on the inside because I knew that I was going to then weld a crossbar between those two front pieces. Having a tripod with me enabled the filming of this time-lapse documentation of production to be really easy. Then I began to hoist the crossbars that would then be drilled through to hold my engine and seat in place. So using the magnets the school had again, I managed to do this quite well. Sometimes, because there was a layer of primer between the earthing cable and the steel, it would be hard to find an arc, so sometimes I'd have to scratch off or sand off some of the primer that the factory applied so that it could arc properly. But then after I started welding, the area would heat up and the paint would be removed from the heat. That's why I bought a respirator, partially for applying primer, but then also if it ever gets burned off, so that I wouldn't inhale the toxic fumes. These short pieces are what I would use to help me navigate where I would put the suspension parts. So when the kit arrived, I could attach it nicely to this box-made area. And then that crossbar at the front is where the steering from the rack and pinion, the pinion would sit on that bar. And then, the rack would sit on that bar. And then the steering column would go through the floor plate up to where I would be. And then I would have steel supports going across the armrest bars, meeting in the middle where the steering wheel will be. So I just went on every angle, welding all the seams. Me and my friend Aiden kept rotating, which was very helpful to have him there because my project, having the 2.5mm thick square box hollow section, can be quite heavy. Some angles were a little bit trickier to get to, so I had to do lots of rotating of my project to reach those angles, which was an inconvenience at some times. But when you have a project that uses two different axes, you're going to expect some rotating to happen. Then I started grinding down a lot of the welds that I did on the outside in areas that didn't matter as much for attaching in terms of attaching new pieces. I decided to wear a face shield instead of normal glasses because I've had 3 incidents now where I've gotten metal in my eye from grinding normally because it bounces off my cheek and goes underneath the glasses. This is why I normally use a face shield, because it doesn't allow any sparks to go anywhere near my face. Again, I wasn't wearing an apron for this part, but I thought that because of the way that I was grinding, no sparks would hit my shirt. So now I started cutting out the custom seat made out of aluminium checker plate. I ordered 2 big sheets of checker plate, and this was just one of them that did most of my project, and I still have a spare sheet. So you can see a piece already missing from this section, and that's because I had made a prototype seat, and this would be the second seat that I had made. So I marked out where I would need to cut with the jigsaw, and I cut off that extra bit to make it easier to store the spare aluminium. And then I cut again with the jigsaw along that edge, just so that it wouldn't cut anybody and be a WH&S issue later. And then I scrapped those skinny bits of aluminium because they were quite sharp. Then I clamped it back down again and weighted it down to be jigsawed again in the desired shape, using wood to reduce some of the vibration. Later I found out that the angles that I'd actually cut with the jigsaw were a little bit off, so they didn't meet properly in the way that I desired when I bent the seat to the 90-degree angle. And now we have, when I had bent the seat and started making these custom gussets that would hold with rivets the corners of the lips together to keep it at the 90-degree angle and be able to support some weight. So I was going back and forth, doing some rough cuts and little sketches and scratches in the aluminium to see how it would work. I was cutting and bending and cutting and bending, going back and forth, just trying to get these pieces correct. Because of the funny angle that it was at, this took quite a long time, but I ended up getting the result that I desired. You can say I used a steel block and a mallet to flatten out pieces when they weren't right, because I didn't want to waste too much aluminium, although I had a lot spare. A lot of the scrap aluminium I decided to either sell to my friend who had melting equipment at home, who could then sell it at its melt value, or to melt it myself and sell it myself. So then I drilled the holes and started riveting the custom gussets on to the custom seat. I chose checker plate as material for the seat and the floor and whatnot because it had a decent amount of grip compared to just flat aluminium, and it was a little bit more difficult to scratch, and it was a bit harder to tell when the checker plate side had been scratched, so that when it's been heavily used it won't look as bad as if you just had flat aluminium. Especially when it has a shiny finish, when a scratch is there you can certainly see that there's a scratch there. That's why I had the flat non-checkered side face down in most of the parts that made out of the checker plate aluminium. I had a decent sized lip that I bent down where the legs would go down off the seat, and then a little lip in the back, so then when you leant back it wouldn't dig into your back. So then I started fitting on the final custom rivet on the other side, bending it into place, making it fit that odd shape of that corner. So you can see I've got a little bit of a lip around the seat, and that's there so that when you go around a corner that lip will catch your hip bone so that you won't slide off the seat and into the frame. Other parts like my floor and the side panels of the cabin and the battery compartment will be made out of this sheet aluminium as well. I had to hacksaw off the extra bits of gusset. And then we move on to the seat crossbars that would be drilled into to hold the seat in place. Because all of this is custom, including the seat, I was not limited to a certain distance apart of bolts and nuts and threads and all that sort of stuff. So I could just drill straight through both of them and then put in some screws of my desired choice. So this is me tapping the engine area. So I had to do 3 different taps, which you can see me swapping out. And then I would use some custom screws to fit that in. Here's some grinding of some parts that I'll show you later. And this is the test piece that I used for testing my weld settings before welding. This is just the T section, so I can practice doing the corners and then also practice on the normal surface. At this point in time, it is now covered in weld, and that is a fairly old picture. Here are some of my first welds. They weren't the best, but after a bit of practice, they started to improve. This picture here was a little bit smoother, mainly because it was in the corner, but doing outside welds and welds where I have to go down a surface or up a surface can be a bit tricky, especially with dripping metal. But again, after some practice, I got the hang of it. Some welds are a bit short, and then adding some would just make it look a little bit worse. But then after some grinding, it looked a lot better. And then I applied some primer to all of it to prevent oxidization. So this is the finished holders all welded in place. And then here's some close-ups of the sanded down and painted weld areas. I was quite happy with them, how they turned out after the grinding. Nice and smooth and with no sharp burrs hanging out. Then I fully painted the entire frame and prepared it for the tapping, which I probably put a bit too early in the video. This was not the final color that I would choose, but just so that it would prevent oxidization at the moment. During the production, I applied this primer, and then later I would apply another layer of primer in my project after cleaning it, and then apply the final paint, and then maybe a gloss to protect the paint underneath, like a plasticky gloss. Drying took a while. This was about half of a double period, so maybe 1 period to completely dry before it was safe to bring inside. I covered every corner, every nook and cranny, every gap, every little hole, and didn't miss a single bit. I applied a nice, even, smooth coat, and it looked really nice at the finish. Then I marked out the seat holder with some lines and some dot punches for the drill to go through. And then I drilled pilot holes and the final holes ready for the seat screws to go through. And then I did the same on the other side because I couldn't go through all the way through with the drill at once. And then I began to attach the seat. So I aligned it to see how well it would go if I went straight through. I did have to do a lot of adjusting with this and adjusting of the holes. I decided not to thread these holes because it would just mean that I had to do it really accurately, and I used a file to change the size of the holes in the seat because I knew that the bolt heads would cover up any small mistakes that I made in the bolting of the seat. It was also really easy to do this because it was made out of aluminium. And then I placed it on the frame to see how it would align, and the holes seemed to align pretty well, but then after a little bit more adjustment, they aligned really well, and I was happy with how it aligned. And then I began to slide the screws through, and with some custom screws that I found in the scrap bin a little while later, I was then able to weld and mild steel custom screws and nuts to the frame permanently to hold the seat in place. Then I tapped and threaded the holes for the engine mount, and then got some screws that would fit through the holes nicely with the threads, ready for the engine. And then I started cutting with the jigsaw outside the parts for my floor, which would then go from the leg lip of my seat to the upper front of my project and over the steering area. Here is a bent saw blade from the jigsaw because I was apparently going too fast and I didn't allow the machine to pull itself along. So I learned that the hard way. So then I finished the cut. It was a little bit inaccurate, but it looked pretty good at the end. And then I just did some more accurate cuts because that was a rough cut, and then I did the proper cut. And then I sanded down the edges so they wouldn't be sharp, and so I could transport the metal more easily. And then back to this. This is the video of the grinding. So these are the gussets. So I drilled a hole in the middle of this square bit so that I could fit the rounded corners of each gusset into the weld corner of the corners that they were going into. The pieces ended up looking a bit like this, but I removed the burrs after they had been cut because they were cut with a grinder, but I did just a fine job with that. And the welds that I did with these bits were really good. I was really happy with them. It looked almost like a machine did it. Then I painted over them the seat nuts and bolts, and then I welded in the final gussets into where they needed to go. And then I don't have any photos for this, but I began testing the sizes of the floor and how it fitted with the gussets, and it turns out that it was a little bit too long for the gusset placement, so I could adjust the aluminium later. But to date, this is how far I've gotten with my project. I hope you enjoyed this time-lapse video of my project documentation and production. Thanks for watching.